That's it. All right. Right. We're on. Go ahead.
Okay, I'm Gage. I'm here. Hello, everybody.
I'm Joachim Ronström. I'm also here.
I'm Matt Knott. I'm here.
Cool.
Very official.
Yep.
So who's the leader for today?
I don't know.
I'm not sure. I don't know where the list was at. I lost
Okay.
that.
So did they say we're gonna do 2 weeks in a row?
I remember something about that.
Okay. I'll just do it today as well then.
So okay, you do it today. I'll do it the next 2 weeks if that's
Sure.
you guys. Okay.
Cool.
Sure.
And then I'll follow.
Sweet.
So we're gonna do logarithmic differentiation part 2, and that's the preparation B activity for day 4. Yeah. So let's get started, I guess. Do you guys both have it printed out?
I'm just looking at it online, but that's
Okay.
fine with
Okay.
me. I have a paper and pencil to write everything down.
I've already done it.
Okay.
All right, but so let's see. Should we just read through it first, like the top part?
Sure,
Yeah,
I can
that's
do
fine
that
with
if you
me.
want. I can do that if you want.
Go ahead.
Okay. As you saw in the prepare activity, you can use the properties of logarithms and logarithmic differentiation to simplify the process of taking the derivative of complicated products and quotients. The fact is, however, you could use the product and quotient rule along with the chain rule if needed to do those problems, but logarithmic differentiation is often easier.
Okay.
That was my radio voice, by the way.
Nice.
That's a nice
Like
radio
it.
voice.
Thanks, guys.
So if f of x equals x to the x power, is it a power function? Why or why not?
I think a power function doesn't have to be a constant, not a constant. Like
A
has
number?
to be, the power will be like 2 or 3,
Yeah.
not a variable.
Yep. That's what I said.
Okay. Yeah, I was going to agree with that too.
So the next one.
I would say yes, because it does have an exponent.
But then do you have to have a constant or like, well, you have
I
to
guess
have
it's
a
actually
number.
it's asking if it's an exponential function. Sorry, not a. I stopped at exponential. Yeah, I don't know.
So I said no, it should have a number there, but maybe.
If you keep reading in the next line, it'll tell you no.
Yeah. Okay. There you go.
But so I guess my question is, what is x to the x powered? So like that function that they give us, what is that considered?
I guess it's just not a function, is it? Isn't it?
I mean, it is a function.
Some type of a function that we haven't
Yeah, I
learned
guess.
about yet.
Yeah, but I guess the only way to solve it is kind of like a logarithmic one.
Yeah. Huh.
Yeah, it would be a log function. I think. I don't know. I don't know what you would call it, but
Yeah. Well, that's okay. I just had the
Okay.
question. That's not too big of a deal.
so if we're gonna take in number 1, we're gonna take the derivative of it.
Uh-huh.
So how would we do that?
So would you do like log base x times x?
So I think you gotta log to both sides. So you have like y equals x to the x power, and then if you log both sides, I instead of fx I just put y. So I put ln y equals ln x to the x power, and we know that we can bring the power down.
Yeah, in front of the x, in front of the ln.
Yeah. And that we can take the derivative of. So we'll have to use implicit differentiation, isn't that what it's called?
Yes.
So that gives us
dy. We'll take dy over dx. You know, I don't know.
okay. So
Any ideas, Matt?
No, I'm actually looking over notes for logarithms to.
okay.
So
where are you guys?
So I have the ln y equals x ln of x.
Okay.
Um.
Do you get that far, Matt, or?
no, but it's okay. I'm working through it slowly, so I'm trying to like.
Okay. So
It's
where
okay.
are you at? Where are you at?
I just converted it to a log.
Okay, so you have ln y equals ln x to the x power.
Yeah.
Okay. Do you remember that if you have a log or ln log, or like when it looks like that, you can bring the
Natural
power
log?
in. It doesn't matter which log you have, as long as you have a
Yeah.
log, you can bring it in front of the ln or log, the power.
Yeah. Yeah.
Do you remember that?
Yeah. So it'd be ln y equals x ln x.
Mm-hmm.
Okay.
Okay, so if we first start to take the derivative of ln y, so
So it would just be 1 over y because you can drop the
yeah.
'Cause
But
the
remember
ln,
that y has a function in itself, so you have to take the derivative of y as well.
okay.
So
So you
it'd be
have
x of to the. I don't know.
so just keep it as a y for now.
Okay.
So when you have ln y, so you know that the derivative of ln y is 1 over y, right?
Yeah.
Then, since there's a function in there, you have to take the derivative of that as well. So you just set y prime or dy over dx times the 1 over y.
Okay.
Does that make sense?
That does make sense.
Yeah.
Okay. So what you get there is y prime over y.
Yes.
And we also take the derivative of the other side. And the x ln x, we have to use the product rule there. Because it's two things multiplied together.
Yeah.
So first we take just the x and then the derivative of ln x. The derivative of ln x is just 1 over x.
Mm-hmm.
So x times 1 over x.
Is just 1, isn't it?
Yep. And then we also have to take the derivative of x times ln x. And the derivative of x is just 1. And then ln x. So what do you guys have so far?
So 1 over y dy dx is equal to basically just ln x.
Plus 1.
Oh, plus 1. Oh, sorry. I thought they were multiplied. Okay.
Well, you have the reason you get 1 is because you have x over x.
Yeah.
And then, oh, you thought they were multiplied. No, because in the product rule you have the plus sign in there between.
Right.
Remember?
For the constant, yeah.
Mm-hmm.
Yeah, so that's why, okay, 1 plus ln x.
Yep.
Okay, so then we want to get the y by itself then, don't we?
You want the y prime by itself.
Yeah.
Yep.
So we divide both sides by dy dx.
So what you want to do is isolate y prime or dy over dx.
Okay. So then divide it by 1 over y, or the...
You can multiply by y,
Gotcha.
both sides.
So then we'd have y prime equals y times ln of x plus 1.
Yep.
Which we can factor that in, can't we, or not? Because couldn't we get dy dx is equal to y plus y ln x?
Technically you can do that.
Not necessary, though?
No, so what you want to do here is, so we know that y equals x to the x power.
Okay.
So at this point we want to plug that back in.
Okay.
Okay.
And that's our final answer.
So then we'll have ln of x plus 1 times x to the x power.
Mm-hmm.
Okay. Are you good, Matt? Any questions?
No. No, it makes sense. It's just looking at it, I still don't think I could do it on my own. But that's why
Yeah.
I'm going to the tutor.
I feel like that too sometimes. Well, a lot of, like, every day.
Yeah. I'm like, okay, I can see that. I'm not really sure. Yeah.
Yeah.
So. Okay.
Just
well,
practice. Just practice. That's how you get
Yeah.
it.
Yeah. Okay. So the next one then. Let's look at that one.
Why don't you start us off?
Sounds great. Okay. So we're just gonna plug in y just because that's easier for me to work with. So y equals 2x minus 1 to the x squared plus third power.
Plus 3.
Plus 3. Sorry, x squared plus 3. Yeah, all in. I don't know. Okay, so now we want to find the derivative of it. So we need to find the derivative of y, which we know is hold on, 2. How does that work out? So it would be. Hold on.
So you would log both sides. You take the ln of both sides to bring your power down.
Okay, that's okay. Okay. I'm just wondering if use substitution would make this one easier. I'm not going to bother with it. All right, so x squared plus 3 ln 2x minus 1 ln y. Okay. So 1 over y is equal to x squared plus 3, I guess 1 over, oh, I guess I don't need to do that though.
What did you say?
Well, I was just trying to get rid of, now that we put the natural logs in, trying to do them differently. That's not the right word, but like converting ln y to 1 over y, and then I was debating doing 1 over 2x minus 1 instead of ln 2x minus 1. Is that what we do?
So first thing you want to do is to bring the power down. Did you do that?
I did that, yeah.
Okay.
So I have x squared plus 3 ln of 2x minus 1.
Mm-hmm.
So then from there, in my own mind, I would put x plus 3 multiplied by 1 over 2x minus 1, just because that's easier for me to understand.
Oh, yeah. Yep. Minus 1, you mean?
Yes, minus 1.
Yep. That's correct. There's one more thing to it, though.
Oh, yeah? What am I missing?
You got to take the derivative of the bottom fraction, too.
Oh, okay. So multiply it by 2?
Yep.
Oh.
Okay, that makes sense. Okay, so
Did you already do the y?
Yes, 1 over y, the ln y, and then
1 over y, and then you have the derivative of y as well.
Right, I didn't do that.
The y prime.
Okay. So now
you have a little bit more to do there. Remember, that's the product rule. So you've done one side of the product rule. X squared plus 3 times ln 2x minus 1. You see that?
Okay. Yeah.
Okay. So you took the derivative of the ln 2x minus 1.
Yeah.
Now you gotta take ln 2x minus 1 and the derivative of x2 plus 3.
Oh, okay. So that would just be 2x. Am I wrong on that?
Huh?
The derivative of x squared plus 3 would just be 2x, correct?
Yeah, but then you also have to multiply that by ln 2x minus 1.
Okay. This problem is getting very complex.
Well, it's almost identical to the last one. It's just like there's more parts
more
of it.
stuff. Yeah.
Yeah. Like so, I feel like the parts kind of get lost.
Does somebody else want to take over? Because I am lost right here.
Okay. What do you have? What do you have?
So I have 1 over y multiplied by y prime equals x squared plus 3 multiplied by 1 over 2x minus 1 multiplied by 2 multiplied by 2x multiplied by ln of 2x minus 1.
Okay, so...
Did I screw that up?
No, there's everything but one thing. So you said x squared plus 3.
Yeah.
That's correct. And then you have 1 over 2x minus 1 times 2.
Yeah.
Did you have a multiplication sign after that?
Yes.
Okay, there's a plus. Yeah.
Okay.
So my question is really quick. Where did that times 2 come from?
So when you take the derivative of a log or a natural log, say you have like, in this case, ln 2x minus 1.
Yes.
You have 1 over 2x minus 1. And then you take the derivative of 2x minus 1 as well.
Okay, that makes sense.
And
I didn't realize you had to take the derivative of the 2x minus 1 as well. So okay.
So I guess we could just simplify that.
Okay. So then we would be
So then basically you just multiply the y over and then substitute the 2x minus 1, what we started with, back into the end of that problem.
Yeah. So what did you get for your answer for that?
So I've ended up with 2x ln of 2x minus 1 plus, and then this is kind of where, because we have the 2, so yeah, I'm kind of lost there so far. So we have the 1 over 2x minus 2 times 2.
Minus 1.
Minus 1, yes, sorry. Minus 1 times the 2, and then times y, correct?
Well, here you still have the x2 plus 3 and the 2. So think about that as all in one parentheses.
Okay. So
if it helps you, what you can do is you multiply all parts, like make it into a fraction. That makes it easier to see. So if everything has a fraction on it, you multiply the whole top together and the whole bottom together.
Whole bottom together.
Does that make sense? So x2 plus 3 divided by 1. So you multiply x2 plus 3 times 1 times 2 and put that over 2x minus 1.
That makes sense now.
It makes it easier to see if you like make a 1.
Put it on. Yeah. Does that make sense, Matt? Are you doing okay?
Yeah, that does make sense, yes.
Okay, I see it now. I was just confused. And then you do the times y outside of that parentheses.
The times y is multiplied by everything you have on that side.
Yes.
Yeah.
Okay, I can see that. So then this is what I have. I think we're on the same page. 2x ln of 2x minus 1 plus 2x squared plus 6 over 2x minus 1, all multiplied by y.
Yep.
Okay.
Then you just substitute your y back in from the beginning of the equation, and that'll give you your final answer. So you remember what we started with at the very first of the function? It was y equals 2x minus 1 to the 2x squared plus 3.
Yep.
Yeah.
Yeah, just substitute that back in, and then and that's multiplied by everything.
Yep.
Sweet.
Cool.
At least we don't have 20 problems like we did last time.
20 problems?
At least we don't have 20 problems like we did last time.
Oh yeah.
Yeah.
No kidding, man. But last time was good though. I had to email her about some questions about it.
Yeah, I learned a lot. I'll do a lot better with these group things.
Yeah, it's nice to have a setting where we can talk about what our challenges are with it. Makes more sense.
Is there any like other questions you guys have?
Not that I have right now. I still have to do all today's work and tomorrow's and then the test. So.
Yeah, same.
I'm not as far ahead.
Well, I'm working ahead just because I was going to take the test today, but I couldn't do it, and I need to get out of town. I'm going out of town tomorrow, so I need to like get everything done.
Yeah.
So